Mr. Schreiber is back. He has figured out the video. Hi, I'm Mr. Schreiber. And he is ready to teach you about slope-intercept form. He is also not going to be speaking in third person starting now. Okay, so today's lesson, it's kind of a big one, big monster one. This is another one where if you ask your parents about slope-intercept form, I'm guessing some of them will know what it is because it's something that's going to follow you guys all through high school. And today's lesson is all about that all lines, when you draw a line, no matter what, it has a relationship with an equation. So an equation actually creates a line. All equations, no matter what, create lines. In fact, people use equations all the time to determine how lines will look over time. People actually, because of the coronavirus, people used equations like this to determine the spread of coronavirus and things like that. They used equations like this. We actually even had a math teacher who did that in the district. So pretty cool that you can use any type of equation to relate to a line. The question is, how do you write an equation to represent a line? How do you do that? Now, before I tell you, and again, I could just tell you what I'd like you to do, this is the part where I want you to be thinking, is that I have 4 lines here. I have 4 lines, and I'm going to show you guys each of these as an equation. So this first one, it is y equals negative 2x plus 3. That's not a random equation. That relates exactly to this line. I want you to think about right now, before we actually go into it, what do you think the 3 stands for? Take a look real close right here. Do you notice something where the 3 would be? And where do you think the negative 2 is represented? And I'll give you a hint. Slope is in there, and what we call the y-intercept is in there, which we haven't talked about yet, but I want you thinking about it. Those 2 things are going to be very important. And so how do you know what this is? Well, y, you guys know this is y. Y is always, in this case, negative 2x plus 3. So whatever x is, you have to multiply that by negative 2 and then add 3, and that will always give you this line. Let's take a look at another one. Again, if you don't understand this right away, that's the whole point of this, is to kind of get your brains thinking. Maybe you guys, stayed up late last night and you're just seeing this in the morning, so we're trying to get your head kind of wrapped around what we're talking about here and to make you think a little bit. So here we go. This one is 4x minus 2. Y is, and you can think of equals as an is, y is 4 times x minus 2. So y is always going to be 4 times as big as x. And then you're always going to take away 2. Take a look here. Do you see where maybe a negative 2 is? And do you see where a 4 is? Here's your hint. Ready? I'm just showing you guys your hint. That was your hint. Not a very good hint. Okay. Let's keep going. Let's take a look down here. This formula is x plus 3. Where do you see a 3 here? Y is going to be, so how do you know what y is? Y is always going to be x, going to be equal to x, same thing as x, right? Except it's going to be plus 3. You're always going to add 3. So for example, if you plugged in 5, let's say x is, actually no, let's do a better one. X is negative 2. Let's say x is negative 2. There's x. What would y be? Y is negative 2 plus 3. Y would be 1. Let's check that. Ready? Watch this. Ready? Negative 2 up 1. Yep, it does work. And you can plug in any number into this, any number for x. And when you use this formula, you're going to get y. You're going to figure out what your y is. Let's try another one. Take a look here. This is y equals 2x minus 1. Now my head's almost in the way. Almost hitting it. But can you see where the negative 1 is? That's actually the same thing as this, a negative 1. And what does the 2 represent? Well, before we do that, let's just plug in a number. Let's plug in a number like 3. Let's say x is equal to 3. So plug it in here. You can do mental math. 2 times 3 is 6, plus 1 is 7. So y equals 7. So when x is 3, watch this. Ready? 1, 2, 3. And we're going to go up 1, 2, 3, 4, 5. And that's actually going to go up to 7 there. So that should, actually, I'm sorry. No, Mr. Schreiber's totally wrong. I was catching myself. Try that again. This is live. This is the real deal. So let's try this again. X is equal to 3. See, when you check your work, you find your mistakes, right? So y equals 2 times 3 plus a -1. So y is 5. Much better, Mr. Schreiber. So go here. X is 3. Go over 3. Up 1, 2, 3, 4, 5. Bam! That hits. And that's going to be the formula. So the question is, how do you write a line as an equation? Let's take a look at this first problem. I'm going to promise you it's not going to make sense in the beginning. It's okay. Don't freak out. We're going to go through a ton of examples. We have this scenario. It says Jim and his brother Sam walk from one end of a block to the other. The table shows their record of times in X seconds and corresponding distances in Y feet. Jim starts at the curb and Sam starts 4 feet ahead of him. Very close to social distancing, but not fully. You have to go 6 feet. Both brothers walk at a rate of 4 feet per second. And it says the graph here shows each brother's distance. Okay, so we have each of their distances here. So my question for you is, we have this graph of what they're doing, but what is their equation? What is their equation? Well, the first thing you want to do is you want to find the slope. You want to find the slope. And I'll give you a hint. The slope for both of these is the same. Aren't they going up at the same rate? They're going at the same rate, and you guys can go up here. Ready? Rise over run. Ready? Rise over run. Rise up 4, go over 1. So the slope is 4 over 1. So the slope of each of these is 4. We're going up 4 over 1. But the difference is that Sam gets a jump start, doesn't he? Doesn't Sam, there's my alarm. Get rid of your alarm. I'm going to have to stop it. There we go. Okay. Hopefully it doesn't go off again. But Sam gets a head start. Doesn't Sam start at 4? Doesn't Sam start at 4? And this is called, if you haven't seen already, is where it intercepts the y-axis. So it's also called the y-intercept. And so Sam already starts at 4. So his equation is y equals 4x. Y is 4 times bigger than x. But then we're going to add 4 because he already starts at the y-intercept, which is 4. Jim is just y equals 4x because he's already going up 4 over 1. His slope is 4. Now, again, this is going to be something that's got a little confusing in the beginning, but we're going to go through it, and I'm going to tell you guys the formula to be able to help you solve this. So here we go. How do you solve the formula, or how do you solve for slope-intercept form for any given line? And this is what I want you guys to write down. If you haven't been taking notes down yet, this is what I want you guys to write down. This is a very famous formula, okay? It is slope-intercept form, and it is y equals mx plus b. Okay, so m, what we call m is we call that the slope. So whatever the slope of the line is, in this case for the last problem it was 4, the slope would be 4x, and b is always the y-intercept. It's always where it intercepts the y-axis. And we're going to go over that in a second. Trust me, you're going to see plenty of examples. I'll explain what that is. And the question is, why do they call this b and why do they call this m? Answer that is, you know what? I'm going to have to look it up. Probably because the math gods, whoever decided to do this problem or create this, they put an M here and a B. But I'll have to look that up for you and get back to you. Or if you'd like to look it up, why the heck do they call this B if that's the y-intercept? Not fully sure. But before we do, I want you to focus on y equals mx plus b. That's going to be the formula we use for every single line. Anytime you make a line, it's always y equals mx plus b, and that's the form we're going to use. So if I said, take a look at all of these slope-intercept form equations, what is going to be the slope and what is going to be the y-intercept? We're going to whip through these pretty quickly. That this here, and look, this is our formula, that whatever is next to x is going to be our slope, which is going to be 3. And the y-intercept is going to be a positive 4 because this is where it intercepts the y-axis when it's 0. Next one, the slope here, and you can also call this 3 over 1. It's perfectly fine. The slope here is -2. And the y-intercept is 7. Let's keep going. The slope of the line here is 1/2. And the y-intercept is a -10. Because we could always call this plus a negative. The question is, what happens when you have something like this right here? And what number is always sneaking right next to x? It's not going to be 0. It's going to be 1. So the slope is 1. It goes up 1 over 1. And actually, I should have made that red. And your y-intercept is -3. This is a tougher one. That's a 4 down below. Let's see if I can move this a little bit. That last one, the slope is -3/4. And your y-intercept, there's nothing right here. So what do you call that? You could just say it's +0, right? So your y-intercept is 0 because it doesn't hit the y-intercept. Well, it does hit the y-intercept. It's just going to be at 0. Okay, so even if that's a little confusing, this is the form we're going to use. And I promise you on the next couple ones that we do here, it's going to make a whole lot more sense. I know in the beginning it's a little confusing. So right here, if you had this line, the question is, what is the equation? What is the equation? And so we're going to solve each of these by first finding the slope and the y-intercept. Let's start with the slope. We can choose any of these 2 points. And remember that slope is always rise over run. Always rise over run. So let's just take this point here, and we're going to go up 1, 2, 3, and we're going to go over 1, 2. So you guys can say that the slope is 3 over 2. That's our slope. And the y-intercept is always, if this is your y, this is your x, it's always where it hits the y-axis. So where it intercepts, when that point in the football game where you intercept that point, y-intercept is right here. This is where it intercepts the y-axis. So where is that? Well, look right here, guys. If this is 0 and we're going down, it's going to be a negative number. So -1, -2, -3, -4, -5, -5. Okay, so guys, the question is, what is the equation? Well, if we have these 2 pieces of information, we can solve it because we know that y equals mx plus b. Y equals m is your slope, plus what's b? B is going to be -5. In fact, I'm going to erase that. I'm going to make that just a, thought that was going to be super cool looking. That's just a -5. And this is your equation. That's it. You got it. That's your slope. This is your y-intercept. And that's going to give you your graph. Now let's take one where it doesn't have the line, but we do have the equation. So what's the graph? What's the graph look like? I should say this, Mr. Schreiber. Been rocking out these videos. I'm losing my mind here. What is the line? Okay, let's start with the slope. The slope is, what number is always right here? It's always y equals mx plus b. Y equals mx plus b. The m is always the slope, so the slope is 1. And your y-intercept is always right here. So that is going to be a -3. And again, if I have these 2 pieces of information, guys, I can map this out. So I'm going to use my super cool moment here. And we start always with the y-intercept. It intercepts at -3. So let's take this little dot. Here's 0. And let's start always with the y-intercept, -1, -2, -3. Drop that right there. And then your slope is 1. So your slope is rise over run, which is 1 over 1. It's the same thing as 1. So in this case, start your point here. Let's rise up 1, go over 1. 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 And do you guys see there's starting to become a pattern here? And it doesn't matter where you start. That is always going to work. So I'm going to make my line, go right across that. And I like to kind of have my students always go all the way through it. That is going to be your line. My question for you is, when you have these 2 pieces of information, it doesn't matter what you plug in. Watch this. I don't know, this is kind of dragging a little bit, but just follow along with me. I want you to plug in How about this point right here? When I plug in this point, that should be on the line, right? That is x is 3, y is 0. X, y, check this out. When I plug these numbers in, it better be equal that. Y is 0, x is 3. Doesn't that work? 0 equals 0. Ha! Super cool. And you can plug in any of these numbers along these lines where it hits, and it will always equal it on both sides. Okay, let's take on another one. And again, if you're not getting this yet, that's okay. We're just going to do a bunch of examples. We're going to do a bunch of examples. You feel free to pause it, take a break. If this is taking too long, come back to it. But we're just going to do a ton of examples. Okay, here, how about we start with our y-intercept this time? This is pretty simple. Where does it intercept the y-axis? It's going to intercept where? 1, 2. It's going to intercept at 2. The y-intercept is 2. And your slope, do you guys see how this is already going to be negative? See how it's going down, starting up top and going down like you're sliding down a hill? So in this case, we're going to rise up 1, and we're going to go back, look to the left. We're going to go negative, -1, -2, -3, -4, -5, -6, -7, -8. I want to make sure I'm right. That should be a -8 because that's kind of hard to see. So you know what? We can check this. Check this out. How about we go down -1? Aren't we going down here? Going down. And we're going to the right. 1, 2, 3, 4, 5, 6, 7, 8. And that's going to give us the same answer. We're going to rise 1, and we're going to rise over 1. We're going to go -8. That's going to be a -1/8 slope. So again, how do we write this as an equation? Remember that y equals mx plus b, and y equals the slope is -1/8 x, and then your y-intercept is a +2. This is your equation. This will always work for this. In fact, we can try it out. You can plug in. You can try it out right now. In fact, if you'd like to, I'd like you to pause, plug in this number, plug in that value right there. I want you to plug it in here. It should be equal on both sides. Try that out and then come back. Let's keep rolling. Again, now we're flipping it around where we have the equation y equals mx plus b. Let's write that down right off the bat. Y equals mx plus b. This is your slope. And this is your y-intercept. And let's solve this. Well, your y-intercept is going to be 2. Slope is going to be 2/5, because that's your slope. And if I said you need to graph this, we need to start with the y-intercept. The y-intercept is 2, so it's going to hit right there. There's 1, 2. Okay. Now, how do we find this? We're going to go slope is 2/5. So starting at that point, we're going to go rise up 2. Watch my cursor go over 1, 2, 3, 4, 5. What's the next one? Up 2. 1, 2, 3, 4, 5. Look at that. I just made this one up today, and it fits perfectly. Now we can go the opposite way. We can go the opposite way because isn't 2/5 the same thing as this? Isn't a negative divided by a negative positive? So watch this. How about we go negative? Go down -2, -1, -2, right? Let's go to the left. -1, -2, -3, -4, -5. And look at that. 2, 3, 4, 5. Makes ourselves a wonderful line. So we can use that line here. Bam. Got it. And that is going to give you your line for this equation. Okay, let's keep moving. We're going to do a few more so you guys can see. So, do you guys see how this is going to be negative? This is going to be a negative slope. And do you see where the y-intercept is? Let's start with the y-intercept. Well, the y-intercept hits right at 0. So the y-intercept is going to be 0. And in this case, the slope is, you can take any 2 points you want. How about I start here, and I'm going to go to here. I'm going to go to there. So let's start here, and we're going to go down. That's going to be a negative, -1, -2, negative. Oh, that's a terrible. Gosh, come on, Mr. Schreiber. That's not looking good. Let's try that again. -1, -2, -3. So that's going to be a -3. And we're going to run over 1, 2, 3, 4. So The slope is rise over run. It's going to be -3/4. That's your slope. So again, when you have these two pieces of information, when you have the slope and when you have the y-intercept, guess what? You can do the equation. Y equals mx plus b. Plug in y equals something here, x plus something. And again, the slope goes here, the y-intercept goes here, and that's it. This really is. You don't have to put that plus 0. This is probably the better version of it. Y equals -3/4x. That's it. That gives you your equation. And again, because it's super awesome, I'm gonna prove it to you on the next one. I'll prove it to you on the next one, why it works. Okay, this is gonna be our last one, guys. Again, if you guys need to see more examples, because I know this is a little tricky, feel free to reach out to me and I can do another video conference. I'll do another one this week. We can do this together. Okay, let's start with the y-intercept. The y-intercept is always right here. It's gonna be 7. And the slope is, I'm gonna write this as -2/1. You can put -2 if you want, but I like to put that because we know that's rise over run. Helps me to see it better. Okay, so let's take our dot. I'll use my cool little dot right here. And we find our y-intercept. 1, 2, 3, 4, 5, 6, 7. Nope. Double check that. 1, 2, 3, 4, 5, 6, 7. Go. Good. And then we just start from that point and we go -2/1 because it's -2, rise, run over 1, -2/1. So you'll see a pattern. In fact, if you have an older brother and sister, tell them to get their graphing calculator out, and you can actually plug these equations into a graphing calculator, and makes a pretty cool line every single time. You can actually make up some pretty cool lines by using like exponents and things like that. Okay, and that'll work. There's your line. I'm going to try this out. Ready? I'm going to try out this point right here. And watch, this is my last point. If you've hung with me this long, thank you. I appreciate you. I know it's tough. I know it's tough hearing someone talk this entire time. You know, I know it's tough. You guys have been rock stars this year, so I really just do appreciate you. I appreciate you. But here we go. We're going to try this out. Ready? How about we just plug in this dot? Plug in this dot right there. Choose any dot you want that's on the line. Let's choose that one. That's an easy one. Over 2, up 3. This is 2, 3. When I plug in this, guys, it better give me equal on both sides, or else Mr. Sharp did it wrong. Ready? Y equals -2x plus 7. Well, isn't y equal to 3? So y is 3 equals -2. Plug in your x, which is 2. Oh my gosh, I'm already going to see this works. Oh my gosh. And doesn't that equal, I'm going to squeeze this in here. Whoop. Equals, no, I don't want to do that. 3 equals 3. And that's a good way to check. Yep. If you want to see if you're right, this point right here, this point right there, that better work too. When you plug in that number, that will be equal on both sides. If it's not equal, then you know you made a mistake. Everybody, that is today's lesson. I know it's a longer one, but I hope you're doing great. Please join us for the conference. I'd appreciate that. We talk about random stuff too. I will tell you, if you're watching this, I will tell you the story about my cat that happened last week at nighttime, about 9:30. I'll tell you the story about that, and we'll go from there. Okay, guys, you have a great one. And again, I'd like to say I hope I see you soon.